Hi, everyone. Thank you for the warm introduction. Hopefully, more people get lost when they're driving in San Francisco, because that's our use case. But my name is Chen-Ping, and I'm the co-founder, CEO of Phiar. Today, my talk will be about separable convolutions for efficient implementation of CNNs and other vision algorithms. So first off, let me reintroduce our company a little bit more. What we're working on is AI-powered AR, augmented reality navigation platform for driving. Our first product is augmented reality navigation, a mobile app that you can download on your iPhone. The reason why we're building that is because, take a look at the screenshot that I took when I was in Boston on the lower left-hand side. That's Google Maps showing me where I was and where I needed to go. I looked at that, I had no idea what that meant out of the 10 streets in front of me. I looked up in front of me, still no idea. Had to make a split-second decision because you're driving and ended up making the wrong turn. So that was a pain point that we're going after because we thought navigation is something every driver pretty much uses all the time now, but we're still using a 2D map. However, people already mount their phone with a mount on the dashboard or the windshield, so the camera is already facing forward. Why don't we show people the live camera feed, and overlay your route directly onto that live feed so that all it takes is a quick glance. You'd immediately know where to go, and you'll never make another wrong turn, miss another exit, never be confused. You don't have to read maps anymore. But to make that possible, there's a lot of on-device computer vision we have to do. So that includes road understanding AI, SLAM, path planning, so object detection, lane segmentation, semantic segmentation, everything has to work on the phone, real time, all together on device. So that's where separable convolution is an important part of making that possible. And that's where I segue into my talk today.